Hi and welcome back to part 8. We're going to be, I've done some testing with this so far, and it's really important that you have milestones for testing within your project. So I did some testing on this and found very quickly a few serious problems. One, you can go really fast backwards, and obviously there's something to do with the code and how I calculate what speed you're going at. I'm also not happy with the placement of the wheel collider. So I mean, this is where the collision with the ground is going to take place, and it really needs to be out wider. But if we put it out wider, what happens is the mesh itself moves out wider. So we're going to fix that, and I'm going to show you my theory. And the last thing was I found that when you do a little jump and the front wing hits the ground, it kind of sticks into the ground and flips you over, and you end up on your roof. And obviously that's a bad thing. It could be, I'll leave that for now because it could be in the game manager that when you are on your roof you lose if you're playing up against another player, but we may just we'll leave that for now. I have a method that will hopefully mean that it doesn't tip over so much. So first up was the problem with it going fast backwards, and I think I've narrowed this down to the fact that an RPM, the RPM that you get is a positive value and a negative value, and if you have a negative value it's not going to affect the calculation the same way. In fact, it'll make it worse. So to test it out, I'm going to do this mathf dot abs, and this is absolute values, so it doesn't matter if this is a positive or a negative value, it will become positive. So if it was say -10, it would be 10. And that just sorts out that potential issue with why this is doing it. And so I'm just adding mathf.abs around the RPM at the given time inside this script. So let's test it and see how it goes. And yeah, we had a pretty much immediate response to that. So now the forward and backward speed is set to the maximum RPM, which I have set at 1500. I could change this down in a value just to see that it's actually working, but I believe it is. So that's that first part done. And the next bit was the sticking into the ground when you land from a little jump. So I figure the best thing to do is I'm going to create a new folder because I'm not sure how much bigger this is going to get, but I'm going to create a folder called materials, and inside that I'm going to create a physics material. So I'm going to click create and choose physics material. So the physics material, I'm just going to say metal, call this metal. You see, again, you can click on the little book to tell you if you want any information about that, but basically dynamic friction, static friction, this is the amount of how slidey it is. 0 would be ice and 1 would be sort of like grippy, but it obviously can go above 1. Usually the values between 0 and 1 are pretty much good. I also want 0 bounciness, so I figure a metal will have a very low dynamic friction and a very low static friction. So if I make both of those 0.05, this will be a very slidey material. So it would affect the wheel colliders as well. So I'm not going to change it for the road, I'm going to change it for the body. So the body is this part here, which is got the collider, and the body has where is it? So this is the mesh collider, and under material this is the physics material. So if I drag metal onto here, that should give that a metal material. This happened fairly frequently when I was jumping over this little bit at the front here where the front end stuck in. So that seemed to slide, and obviously I'm going to have to do more testing to make sure that that's doing what it's supposed to do. Yeah, and the last thing was the wheel collider. So I have made some changes because I took the camera out to this prefab. So you'll see if you ever make changes to the prefab that's on your scene, it's not always great practice, but you know, sometimes it's good enough. You just need to make sure that you apply those changes, and there's nothing obvious. It doesn't show you that there's changes being made, but you can go over to this overrides where it says overrides in the inspector, and you'll see that these are all the things that were kind of changed, and I'm going to click apply all. So that means that this one that is on my scene right now will be the prefab. When you double click on the prefab, there's a little arrow on the right here which opens up the prefab view. So this is just like the scene that only contains this model, this prefab with all of its scripts and things in it. So the reason I did this because I did want to show you just how to fix this wheel collider. I want the wheel collider to be at least outside the main body, and I don't mind if the wheels are still where they are, but I definitely don't want them sticking miles out away from where they're joined. So the way I'm going to fix this, I feel, is I could go and open up the model and go and change the pivot point. If you see, you've got pivot and center, they're two different places. The pivot is the point that is the 0, 0, 0 for this particular model, and I kind of want that to be in the middle. So I could go and change the model, as I said, but I'm not gonna. I'm going to do it this way. What I'm going to do, and you probably need to stuff around with this, because what I'm going to do is I'm going to create an empty game object that is then going to be a parent of this mesh. The empty game object is going to be what's transformed by the script. So the empty game object will be moved into the position that it needs to be for the wheel collider for the script. So if I take this wheel collider and I move it to where I want it to be, which is just outside. Okay, I'm going to take a little look at this wheel collider position. So it was minus 0.3. So if I go 0.4, that's pretty good, because that's nice and wide now. And then I can do the same with the one on the other side. But this mesh is in the wrong place. So what I'm going to do is I'm going to create for the wheel collider an empty game object. I'm going to rename this empty game object. As wheel, maybe say left front pivot, which is a reasonably explanatory name, and then I'm going to drag this one onto it so that the left front pivot is the parent and this is the child, and then I'm going to move this back to where I want it to be. So this, something like that, should be good. So because it's a child, it's relative to the parent. So the parent is nice and wide out here, but the child is inside of it. So I don't know if I've maybe put this left front pivot out a bit far. It does kind of look a bit far. It should be the left front wheel collider, sorry, should be a little bit further in, I reckon. So 0.35. 0.35. That's still more than wide enough, I reckon, just outside. And then left front pivot is at 0, 0, 0 relative to that. So wherever the mesh goes as a child of it, it'll move around to be relative to the pivot. So there we go. I'm pretty happy with that. So that's front left wheel is 0.15, and then that way I can match up the values. So yeah, that's pretty much it. You need to do the same with all of them now. So I'm just going to go through that, and I'll show you when I'm done. So as you can see from the hierarchy here, I've managed to add a pivot for every single one, and I've used the same values as well for all of the positions of all of those. So the wheel colliders are now much wider than where they were before, and the mesh is still in a good position. So the last thing that I wanted to do, I'm just going to fold these away for 2 seconds, is for all these 4 wheel colliders, I'm just not sure if it's maybe just too high off the ground or too low off the ground. I'll leave it up to you. I'm going to leave it as it is, but I've left the stiffness values at 5 for the grip, and I'm not sure of whether the amount of spring force is enough. If I do want to lower the suspension distance to even less, so that it's not moving so much, I could put the wheels up and have stiffer suspension, and that mean put the spring value up. But I'm not sure how it will affect the performance of the car. So, you can, if you've got all four selected, you can move them up and down as much as you like. It felt to me that it was kind of looking a little high, but important thing is you just test the thing. So you can see here that whatever it is that I did has managed to not work, because the wheels are much wider. It's a lot more stable, but for some reason it's not working. So I figure the reason for that is most likely something really obvious. So this is done. If I go back to the main scene, it's the same prefab with the same setup with the pivots. The issue I have is that my car script that I wrote, when it takes the wheels, it's actually taken the child of the child. It's taken the front left. So it's looking for the first mesh, or it should be looking for the first mesh. So I'm going to dig that out and explain what I've found out. So a little bit of research led me to this thing inside the Unity documentation with a game object where you can get a game object's child by index. So transform.getChild, and you can go further with that if they've got children of children. So just going to have a little look at implementing that. So rather than what we were doing previously, where we were getting an actual mesh, we want to grab the first child of this game object. So rather than what the script does, the script is on each of the wheels and it looks for the first mesh, which skips by the first transform, and we want to use that. So we're going to get the first child transform rather than get the first mesh as a component. So back to the code, we're going to say mesh is a transform. I've called it mesh, but it's the actual pivot. I could rename it if you want to, but I'll leave it as it is because I think I know what I'm talking about. So we want to say the transform, so this object's transform, and we want to get the child, the first child of it, so that would be index 0. So this changes one line of code where it says just get the first child transform and put it as a mesh. So what it should do, without testing, is it should grab the pivot and it should make the pivot move around based on the wheel collider, not that mesh. So I'm going to save that, hit play, see what happens, and cross my fingers. So there we go, we got that. So what do you know, it worked. So the wheel colliders are much wider now, so that should make the whole thing a lot more stable, and the wheel mesh is drawn in the correct position. And so far, even in this driving, I've managed to spin around, but I haven't managed to get the thing to stick on its roof yet. So here we go, this is a big jump, and no, pretty good. So yeah, I think that's pretty much a fun game. I'm going to stop the series for now. Hopefully you've enjoyed it. If you've got any requests about what you want to do next, then just send a message, make a comment. The couple of options are that we can go for I can add in the game manager, as long as you have an idea of what game we're going to do. Fix that. I could definitely tweak the car code, but it is slightly better, and there's some improvements that could be done. So I've done some, but definitely I might want to leave that here, because I definitely could improve upon that script for things like gearing, and for things like having a brake instead of just applying negative torque. Do I want to have checkpoints? If you're going to make it a race, you're going to have checkpoints. So do I want to add in some AI? The other thing would be how to make it quite simply, it's not that difficult, would be make it 2-player. So yeah, if you've enjoyed these videos, please subscribe and comment. Hopefully you'll have some fun making some levels and playing, driving a little car around, and yeah, feel free to have a go at making it 2-player yourself, or if you want to put some requests in about how to add some checkpoints or car AI, that would be something I could do in the future. So hopefully you've enjoyed it, and I'll see you in my next series.